This is question 13 from the first CSAT sample paper. So here we're given an m times n grid, so we've got a bunch of points, there's m of them going horizontally and n of them going vertically, and they're laid out in this rectangular formation. I put a bunch of dots because we don't know how many there are. And we're asked how many paths are there from the top left to the bottom right if we can only move right or down. So we can go from here to here, or here to here, or we could do this, for instance, and some combination of these is going to get us from x to y, but we want to know how many such paths are there. So for instance, it's obvious we could do this, we could do this, we could do some zigzag thing, or we could do bigger zigzags, but we can only go down and right. So if you want to have a go at this question yourself, pause the video now. Okay, so the way I'm going to think about this is in terms of ordering. So we know we can only go down and right, but we have to go down and right because we have to go from here to here. So that means we have to go right m-1 times. We've got to get from the first column to the nth column. And we've got to go down n-1 times. We've got to get from the first row to the nth row. So no matter what path we take, we have to have gone right m-1 times to get to here. And we have to have gone down n-1 times. And it's just a question of how many orders can we put those operations in. So let's go down and try and calculate how many orders there are. Okay, so first we've got going right n-1 and going down n-1 times. We're putting these in some order. So how many things are we ordering? We've got n-1 rights and n-1 downs, so that's n-1 plus n-1 things total. But we could simplify this, we will later, to n plus n-2. So you might think the answer is just m plus n-2 factorial, because when we want the number of orders of things, we just do the factorial. But the thing is, some of these orders, if I just take all these m plus n-2 things, some ways of rearranging them will give me indistinguishable paths. So for instance, if I take two rights and then two downs, if I swap the two rights around, those count as a different order if I'm just thinking of these as m plus n-2 separate things, but they'll give me the same path, because I can't tell going right and going right apart. So we've got to divide by something to avoid double counting. And what we have to divide by are just the number of rights and number of downs. So that's m-1 factorial and n-1 factorial. So why is that? You could have seen this before, in which case this is a natural thing to do. If you haven't, imagine these are my things I'm sorting, and say the open circles are rights and the dark circles are downs. And I'm sorting, in this case, 7 things. So the number of orders of these things is 7 factorial. But that will count, say, swapping these two dark circles as changing the order. Whereas if we only care about the order of light versus dark, then swapping those two doesn't count as a separate order, so we're double counting. So we need to divide by the number of ways of ordering these dark things, because any way of reordering them doesn't change the answer. So basically, how many spare orders have we got? It's all the orders we get by first laying them out like this, and then just changing these and leaving everything else the same. So because there's n-1 rights and n-1 downs, we have to divide by n-1 factorial, because that's the number of ways of reordering these, which doesn't make a difference, and n-1 factorial, because that's the number of ways of reordering these, and that doesn't make a difference. So what does that make our final answer? Our final answer is, on the top, m plus n-2, because that's the total number of things, factorial. And on the bottom, m-1 factorial, n-1 factorial. So this here is our final answer.